Good morning, everybody. See now, this is the last problem in this chapter 1 now. I will read the problem now. See now, a post-tensioned bridge girder with unbonded tendons. Again, please note it is a post-tensioned beam and unbonded tendons are there. Okay, so a post-tensioned bridge girder with unbonded tendons is of box section of overall dimension 1200 mm wide and 1800 mm deep. In the sense, it's a box section as you see, 1200 mm wide and 1800 mm deep. Was that now 1800 mm deep? I think you can easily see. Was that now 1800 mm deep with wall thickness of 150 mm wall thickness. Okay, you can see here wall thickness is 150 mm. This also 150 mm. Okay, wall thickness. The high tensile steel has an area of 4000 mm square. In a sense, he has given here the area of steel 4000 mm square AP, and is located at an effective depth of 1600 mm. Baba, at an effective depth of 1600 mm, this AP has been now kept. Okay, 1600 mm is your effective depth. AP value also he has given. AP value is now how much now? It is effective depth 4000 mm square it is. Okay, now the effective pre-stress in steel after the losses is 1000 Newton per m square. In sense, FP he has given. FP value is 1000 Newton per m square. FP is 1000 Newton per m square. Okay, and the effective span of the girder is 24 meter. Effective span is 24 meter. If FCK is equal to 40 MPa, FP is 1600 MPa, estimate the ultimate flexural strength of the section. Okay, so now this problem is slightly different. Please try to give this thing attention. Baba, FCK is given 40 MPa, FP is 600 MPa, AP he has given, FP he has given, breadth is 1200 mm, depth, effective depth is 1600 mm. Okay, sir, now, and DF, depth of the flange is 150 mm. Okay, this is the depth of the flange. Okay, 150 mm. And now BW, Baba, BW is, BW means it is the breadth of the web. Baba, this breadth of the web is 150 plus this also the web, na? It's also 150 mm. So now BW is 150 plus 150. Am I right? This 150 plus this 150 will give me 300 mm. Okay. So but now the span he has given as 24 meter or 24,000 mm. So now I will calculate L by D ratio. L I know, effective span I know, effective depth I know. Okay, so it will give me 15 as L by D ratio. Okay, so now I think you came to know why I am calculating L by D ratio, because in table number 12 for different L by D ratios I have the calculation. Okay, so now Baba, let us assume that the neutral axis lies in the web, because now since thickness of the flange is very less, 150 mm. Now directly I will assume that the neutral axis lies in the web. Okay, directly it lies in the web, I will assume. Okay, so now when I assume that it lies in the web, but now AP is split up into APW plus APF. Okay, so now we shall try to calculate APF. APF can be calculated by this simple equation, 0.45 FCK into BF minus BW into DF by FP. Baba, all the values you know, just fill them up here now. BW is now 300. Okay, so fill up the values, you will get 1580 mm square. So now once you know APF value as 1580, okay, now I think APW can be now easily calculated. It is AP minus APF will give me APW. Okay, so APW is AP minus APF. So now AP is 4000, APF is just now you have calculated. So you came to know APW value also as 2482 mm square. Okay, so but now we shall try to calculate this effective reinforcement ratio as APW into FPE BWD into FCK. Am I right? So APW you know, just now you have calculated. FP value you know, BW you know, effective depth you know, FCK you know. Okay, so now this effective reinforcement ratio is 0.129. Okay, so for this 0.129, now by using your table number 12, I have to find the details. Okay, see now so now just remember your effective reinforcement ratio is 0.129. Okay, please remember this value now, 0.129. Okay, so now see now I will go to now your table number 12. Since it is unbonded post tensioned beam and your effective reinforcement ratio is 0.129. Okay, so now 0.129 lies in between 0.15 and zero point 0.2. Is it right? Sorry, it lies in between 0.1 and 0.15. It is 0.129. So it lies in between these two. Okay, for this, Baba, if I want to find out FPU by FP, the value, your L by D ratio is 20. So now I have to take this for L by D. It is 1.26. Sorry, 1 minute. Your L by D ratio is 15, I think. Am I right now? So now here I don't have L by D of 15. Okay, but 15 lies in between 10 and 20. Am I right now? L by D lies in between 10 and 20. So but now again interpolation is required here now. So what I do is now, okay, so for effective reinforcement ratio of 0.1 and 0.15, okay, now I will take the this thing as L by D ratio as 20. Okay, so for that you find out FPU by FP as this much and this much. Baba, this is for L by D ratio of 20. Okay, so now you calculate your corresponding FPU by FP by interpolation. Baba, by interpolation you can easily do it. Okay, so it will give me a value of 1.23. Okay, now you go for L by D ratio of 10. Again similarly find out the value of this FPU by FP, again by interpolation here. Am I right? So you will get the value of 1.41 by interpolation. Okay, so now what you got is for L by D of 20, when L by D is equal to 20, you got FPU by FP as 1.23. Am I right? FPU by FP as 1.23. And when L by D ratio is 10, you got FPU by FP as 1.41. Okay, when L by D is 10, your this FPU by FP is 1.41. So but now again you have to make interpolation here now. Again by making interpolation, now I want the value of FPU by FP when L by D is 15, because it lies in between. Okay, so again you do some interpolation here now and calculate corresponding FPU by FP when L by D is 15. So now when you interpolate it, you will get the value of L by D, in sense the value of FPU by FP as 1.32. Okay, so now once you know the value of FPU by FP as 1.32, okay, so now cross multiply it, you will get FPU value. So FPU value is 1.3 times 32 times FPU. Baba, FPU you know, it will give me 1310 MPa. Baba, in the same way you have to calculate your XU by D value also. Okay, again you have to interpolate the values in between L by D ratio of 20, L by D ratio of 10. Okay, and again you have to interpolate it. When you do that exercise, you will get XU by D as 0.41. So now you calculate XU now by cross multiplying here now. XU you will get it as 656. Okay, so but now but here the several times you have to go for the interpolation. Okay, so now I know the value of FPU, I know the value of XU. Okay, so but now you can easily calculate your MU, the ultimate moment of resistance, by this equation. This is your web contribution plus this is your flange contribution. this equation you should remember now. Okay, so now I think all the values are known to me here now. Okay, if you just fill it up and calculate it, you will get the ultimate moment of resistance as 8011 kilonewton meter. Okay, so now this is how this is slightly a complicated problem, because here you have to interpolate many times the values. Okay, so now please look into this. This is very important problem from the examination point of view. Okay, thank you very much. Bye.